Today, we are going to perform a correlation test using the Pearson R correlation to determine if two variables are indeed um, correlated and have a relationship with each other or not within a big set of data. So those two variables that we are looking at today are free and reduced lunch percentage and the percentage of students scoring at exceeding level in math. But before we can just dive into a Pearson R correlation, we have to determine if Pearson R is indeed the right correlation test that we need to use. So we need to check for a few things. We need to check for normality, linearity, and homoscedasticity. So in order to do that, we're going to go up to Analyze. Well, if this will work, Analyze, Descriptive Statistics, and then Frequencies. We're going to move over Free and Reduced Lunch, Exceeding Math, and then we need to go ahead and click on Charts. Make sure that we have our histograms. We want to show a normal curve on our histogram and then hit Continue. Now, we don't really need to have frequency tables for this test, so we're going to uncheck that and hit OK. Now we can see that our N is at 235. And here we have our free and reduced lunch bell curve here, and it is pretty normal, -1 here. That's pretty normally evenly distributed-ish. And then here we have the math exceeding, and that is also pretty normal as well. So I would say that the check for normality passes. Next, we're going to check for linearity. So we're just going to go up here to Graphs, click on Chart Builder. We're going to click on Scatter Dot and pull that up into this window. And then pull over our variables. So here we have free and reduced lunch, and then we need the math exceeding. Go ahead and pull that over. And what I like to do is I'm going to put our line of best fit, check the total, and hit OK. Now, as we scroll down, we can see among our huge amount of data that the majority of our points are they're around the line of best fit here. You can see that the line has a negative slope, so we do have a negative correlation. And these dots are performing in a linear way, minus a few outliers here and there. So I would say that this would pass the line of linearity test. The next and last thing that we would need to check is the test of homoscedasticity. So what we would do is we would ultimately draw a circle around our data, and if we have a wider middle, but then a lower outside, then it would pass that test. And as you can see around this side, it's a little skewed here. So I honestly wouldn't say that this data would have passed the homoscedasticity test. But we're going to go ahead and we're going to proceed with the Pearson R to see what kind of effect that really has. So what we're going to do is we're going to exit out of this. We're going to go back to our data, and we're going to click on Analyze and then Correlate. Then we have Bivariate. And again, we're going to pull over Free and Reduced Lunch, Math Exceeding, and we have our Pearson checked, we have our two-tailed checked, and then we have flag significant correlations as well. So we're going to hit OK. And here we have our data. So we can see here that under the Pearson correlation, we have a negative 0.696, which is almost a negative 0.7. So ultimately, that would be a moderate negative correlation. It's kind of on the upper end. It's getting close to strong, but I would say that would be a moderate negative correlation between free and reduced lunch and exceeding math scores. So we can also tell from our significance, our two-tailed, it's less than 0.001. So since this number here is less than 0.05, there is a significant difference between the free and reduced lunch and the math exceeding, and it just has a negative correlation among each other. So what that ultimately means is as the higher number of free and reduced lunch, then the less amount of students would be scoring exceeding on the math performance level. So again, if we go back and we look at those graphs, go back to analyze descriptive statistics frequencies. Those are pulled over. We should have our charts ready to go. Okay. I wonder if it kept, oh, it did not keep my linearity. Let's make sure all of that is pulled and set. Okay. Gonna hit okay. Okay. So as we can easily see here, the higher number of that free and reduced lunch, then the lower and lower the math exceeding test score is. So what that means for school districts is that if you have a high number of students on that poverty level, or they have a high economic need, then I mean, we have a negative correlation here of exceeding math scores. So those schools are really going to have a challenge meeting the needs of students if they're in high economic need and wanting to perform well on those state tests. So this would be great data for those schools to look at their numbers and really meet those needs of their students.